Sorry about the abrupt ending of that last video. I may have hit the off button of the iPad by mistake as I was holding it. Alright, so we were just getting our x component of the force that the vertical part of the crane was putting on the arm. And you should end up getting 7,278.19 newtons. And then you're going to do the y part. So sum of the forces in the y, which of course will be 0, MAY goes to 0. And it will be the Fy that we're trying to find, plus the FTY, minus the FG of the arm, minus the FG of the container. So Fy will equal M of the arm G plus M of the container G minus Ft, and the y component is the opposite side, so it'll be sine theta. So Fy will be, the arm was 345 kilograms times 9.81 meters per second squared plus 355 kilograms times 9.81, put a times here, meters per second squared minus the 8582.28 newtons sine of 32. And when you do that, you get an Fy of 2,319.08 newtons. Okay, sorry, I know it's on an angle. Let me straighten this out. Alright, so we have an x component. That was 7,278.19 newtons. We have a y component. That is 2,319.08 newtons. And you're going to square them, add them together, take the square root to get f, and then find theta. And when you do, you get 7,638.73 newtons at an angle of 17.67 degrees, and that will be counterclockwise from the beam, right? Because this way is counterclockwise. All right, so there it is. Torque questions done. So if we were in a classroom, there would be a test coming very soon to a theater near you on torque. Since we're not in a classroom at the moment, we will move on to the next unit. And of course, if there was a test, there would be that assignment that I showed you yesterday. So if you wanted more practice on torque, in the meantime, you could work on that assignment, and maybe someday I can give you that assignment. But for now, the next unit is called two-dimensional momentum. Two-dimensional momentum. It's actually two-dimensional conservation of momentum and energy. But for right now, we'll talk about momentum. So from grade 11 physics, you would have learned that momentum had to do with an object's mass and velocity. And its letter, if you remember, was p. And the equation was really easy. It was p equals mv. And the units for momentum were kilogram meters per second, which, despite my stories that I may have told in the past, has not been renamed. And we also know that it's not so much an object's momentum, but its change in momentum that is most important. Because if a big truck wants to come to a stop, it's its change in momentum that matters. And usually we change an object's momentum by changing its velocity. We don't tend to throw things out of the truck, we tend to step on the brakes. So how do we change an object's momentum? We change an object's momentum by applying an impulse, J. And if we think of Newton's second law, F equals ma, we know A equals Vf minus Vi over delta t. So if we multiply both sides by delta t, we get F delta t equals m Vf minus Vi. But the Vf minus Vi is really just delta V. So we get F delta t equals m delta V. Well, here's our m delta V, so it must be equal to F delta t. And it is, and we call this F delta t impulse. if you remember. We put an impulse on an object and it changes the object's momentum. So in grade 11 physics, we did a fair bit of calculations with that. But in grade 12 physics, we're really going to talk about the law of conservation of momentum, which we also talked about in grade 11 physics. But in grade 11 physics, it was always only in one dimension. But in grade 12 physics, it's going to be in two. The law of conservation of momentum simply says that the momentum before a collision or an occurrence, an event, has to be equal to the momentum after. And if you remember, we had like ball number 1 and it was rolling along and it smucked into ball number 2 that was stationary. So maybe this guy was like 4 meters per second east. And this guy was initially 0. And then after the collision, ball 2 went this way with some velocity that we had to find, and ball 1 maybe went back, v1 final, maybe with a velocity of 1 meter per second west. And then if we knew the masses of the balls, we had to find v2. And remember, it was m1 v1 initial plus m2 v2 initial is equal to m1 v1 final plus m2 v2 final. And then remember that we solved then for m1 and m2. So let's just say m1's mass is, I don't know, 5 kilograms. And m2's mass is, let's say, 8 kilograms. And then we could solve this for v2 final. This term would go to 0 because it was stationary. We'd bring the other m1 over, so it would be minus m1 v1 final. And then you would divide by the m2 to get v2 final. Remember doing this? And then you had to look after your directions. So m1 was 5 kilograms, and it was going initially east, so we can call east positive, minus 5 kilograms. Oops. And now it rebounds west, so we would call west negative. And then we're going to divide it by 8 kilograms. And so you get a v2 final. First term is 20, second term is 5. They're added together. So 25 over 8. So 3.1, what was it, 25 over 8? I could just do it on my calculator. I want to say 625, but I should probably check. No, just 25, not 6, 25 meters per second, and it worked out to be positive, so it would be east. Okay, so that was one-dimensional. But now we're going to look at two-dimensional momentum. So now we have ball 1 coming in. We can say its mass is still 5 kilograms. And it's coming in, we can, and it hits ball 2, which is still stationary. So v2 initial is still stationary. m2 we can still make 8 kilograms. But after they hit, one's going to go off one way and the other is going to go off the other way. I forget what I told you that v1 was over there, 4 meters per second east, so we can still use that. So v1 initial, 4 meters per second east, and maybe after the collision it goes off at a speed of 2 meters per second and maybe at an angle of 30 degrees. And so the question is, what's v2 final? And so the good news about conservation of momentum is it holds in both directions. So now what you're going to do is you're going to do m1 v1 initial x plus m2 v2 initial x has to equal m1 v1 final x plus m2 v2 final x, and then you're going to do it in the y. m1 v1 initial y plus m2 v2 initial y will equal m1 v1 final y plus m2 v2 final y. Okay, and so this one we can find its x and y components, v2, v1 fy and v1 fx. We can find them because we have the hypotenuse and the angle. And so in each of these, then we're looking for the v2 fx and the v2 fy. Then when you get them, you put them together and you do Pythagorean theorem, v2 fx, v2 fy, to find v2 f and theta. Okay, so homework.